In this video, we're going to have a look at how we can calculate the volume of three particular shapes. So the first one being a square represented in 3 dimensions, so a cube. Second one being a circle represented in 3 dimensions, so being a cylinder. And then finally, the cylinder, or a cylinder with a cylinder cut out of it, so a circle with a circle cut out and then expressed down. So sort of like a piece of pipe in that there's a hole going down through the middle. So looking up, recall that a cube is a 3D manifestation of a square. So if we recall to the area of a square, it is the side times the side. For the volume of a cube, it's similar to that in that rather than just being a side to a side, it's a side times a side times a side. So volume is simply the side times the side multiplied by the side. In this case, it's going to be 50 times 50 times 50. And using some mental arithmetic, 5 cubed is 125. And therefore there's 50s, so it's going to be 1, 2, 3. So it becomes a volume of 125,000 millimeters cubed. So not too hard there. Going down, if we're going for a volume of a cylinder, again, think about what is a cylinder. Well, it's simply a circle represented in 3D space, or it's a circle with thickness. So the way in which we're going to do this one is we'll simply calculate the area consumed by the circle and then multiply it by its height, so how far it's been extruded backwards. So the volume is going to be pi r squared multiplied by the height. Now if the radius in this case is simply 30, then it's going to be 30 squared, and if the height is that, then it's going to be times 70. So doing the calculation, 3 squared is simply 9, so it's going to be 30 will be 900 times 70 times pi, and 7 nines are equal to 63. And then 0, 0, 0, pi, and that again is millimeters cubed. Notice I haven't evaluated the value of pi there, and the reason being is that if I leave it in this form here, then it's in its most exact form that we can go for. If I turn pi into its numerical form and then multiply it by 63,000, then what I end up doing is getting some, or introducing some inaccuracies into the final result. So right now we're in exact form. If we evaluate pi, we get an irrational number and then we lose precision. So we're not going to do that. All right, moving on. We have the volume of a cylinder with a hole in the middle. So effectively a piece of pipe. Now notice that the calculations above, or the measurements above, are similar to the measurements below here, except there's this hole cut in the middle with a radius of 10 millimeters. So what we're going to find is that if we go for like a shortcut, then our volume is going to be, say, 63,000 pi, take away, and that will be what will it be, pi times 10 squared times 70. But that's a little bit long-winded. So what we'll do is we'll think about it from a different perspective. Think about the face drawn with this circle. So the outer circle with a radius of 30 millimeters and then the inner circle with 30 millimeters. If I were to draw, say, the circle itself, and we're going to go circle, not quite, a circle like that, and then a circle like that, what we find is that we've got a radius of 10, then we've got a radius of 30. So if we're going for the area here, then it's going to become a value of area. So the area being this blue part here, it will become pi r squared take pi r squared, and we need a 1 and a 2, and it will be the purple one take away the red one, like so. Alright, so evaluating this, what we're going to find is pi 30 squared take pi 10 squared. Doing some factorization and taking out the pi, we find it's pi 30 squared take away 10 squared. And then evaluating this, pi 30 squared is equal to 900, take away 10 squared, that's 100. So what we get is 800 pi millimeters squared. Now remember, we're not going for area, we're going for volume. So to do the volume calculation, all we need to do is simply get this 800 pi and then multiply it by the height. So in this case it's 70 millimeters. So what we indeed find is that the volume of this particular shape is 8 sevens are 56, so it will be 56,000 pi millimeters cubed. So this would be our volume here. So the take home is, if we've got a cutout from our shape, simply calculate the main body of the shape and then take away the section that's been cut away. So you can either calculate the volume of this center part again and take it from the outside, or you can simply calculate the area of the available space and then extrude it downwards. So this has been a video on how to firstly calculate the volume of a cube, then the volume of a cylinder, and then finally the volume of a cylinder that's had part of its in a cylinder taken away from it.